This is a reading guide of cave bears. Wow!
All right, this article is a pretty exciting one because it's looking at two extinct bears and the brown bear. So it's a modern bear, except that they're looking at ancient samples of it. So pretty interesting bear paper. The introduction is going to give you some information about bears. That's helpful, and it's going to tell you, of course, the background of what other people have studied.
On me.
Okay, and actually, when you get into the second page here, this is a lot more about the previous research that led to this study. And they're going to give you their research questions up here, and you're going to want to track and as you go through this and see if they answer those questions and how well they're able to answer those questions. Then, of course, they're going to describe how they do their study a little bit here, and then get into the real specifics with the materials and methods. I'm going to explain a couple things in here. I went through, and these are where their samples are from. I went through and marked down each of the locations at the very beginning. It turns out you really only need to know a couple of the locations. So, pay attention to where their study site is, their Ramesh Cave and the Gemsulsan Cave over here. And you might want to know where the Bala Column is. It's around number 4 here. And Dij Babe over here. Otherwise, you can go back and look at them if you need to, but just get an idea that there's... Okay, I'm talking on the reading guide, so can you please go out of the room? That would be very helpful, or at least be quiet. Thanks. Okay, so going in through here, they're going to tell you, about where their materials came from, the modern material, paleogenetics here. This, we will talk about sort of paleogenetics, I guess, in the museomics unit that is coming up. So you don't need to spend a lot of time figuring out what their methods were for ancient DNA. Suffice it to say that they use DNA sequencing of known regions that would distinguish among the 3 species, or subspecies in one case. So you don't need to worry about that. And then basically this bone preparation and isotopic measurements, what I essentially want you to get out of here is that they used a mass spec that had an elemental analyzer. You remember we read that the combination of the two was important. So that's pretty much good enough for those methods. Then when we get over here, they're going to start explaining why they chose the different isotopes, the different oxygen isotopes that they used in this. And it turns out, I glossed over it a little bit at the beginning, but it turns out to be important to know that there are 2 different kinds that they use, right? There's the isotope composition of phosphate, and then, let's see if I can find the other isotope here. Well, they're going to tell you, somehow I don't have it highlighted here, or maybe this is just about the phosphate. So here you go. This is about phosphate measurements that they're getting out of oxygen. They're going to do other oxygen measurements as well. So just know about the phosphate, that you can use oxygen to determine phosphate as well. They tell you about the standards that they use. You already know about standards, so you can kind of skip over that. Then here they tell you the statistical analyses that they did, right? And you need to know that for your message box. So double check as you're going through that that's all they did for statistics, but that's the main part where they distinguish, where they explain their statistical tests. Okay, in the results, they're going to tell you that they were successful at identifying the species using DNA. That's great. And then they're going to go into a whole series of results. So at first they're going to tell you that they had to look at the isotopic signatures of modern grizzly bears. That they explain why they do that, and then they explain that this worked. So take a look at why do they need to use modern grizzly bears? What were they accounting for there? You'll remember our bulleted list. This is getting at one of those items on there. So make sure you're ready to talk about that. Then we go into the carbon and nitrogen composition of bone collagen. And this is something you have to do when you do ancient isotope studies, or you have to verify that your sample is preserved well enough that you're getting the right isotopic ratio. So here's where they're verifying that their samples were preserved well enough to be able to compare them with modern specimens. So this is another one of our bulleted list, right? Things that you have to do to be able to say that your study is valid. Okay, now we're going to actually get into what they found in terms of the isotopic signatures from the ancient bears. And this is where it gets pretty complicated. So I went through and I wrote down what they were finding on the side for each one of these things, including the tables, but it gets complicated, and that's fine, but it means that you're going to need to be really careful about keeping track of what each signature tells you, and the fact that each signature can tell you several different things. So let's go on to the next page where we get into a figure here. So they don't tell you much in their figures, unfortunately. So one activity we might do is maybe rewrite the legends to tell you what the take-home points are. One thing that they do down here is they explain a little more about preservation and deterioration and how it could have affected the carbonate isotope measures. So that's essentially what they're getting at down here. So that's the diagenetic alteration that they talk about. Okay, now the discussion is where they're going to interpret their results, and it's interesting because they're introducing figures, I think, in their discussion, which is not normally the way that you would do things. Normally, your figures need to all be introduced in your results. So that makes this paper a little confusing to read as a result. So something to keep in mind when you're writing your own papers. So first off, they're going to add in a cave lion. Why do they add in a cave lion, and what does that tell you about the other values that they're showing? I'm going to skip down here. I, of course, marked off all the things that were significant, that had significant p-values in this table 4. And table 3 gives you a summary of their isotopic data, but it's really not that helpful. So don't worry about table 3, but table 4, checking on what values are significant is helpful, and then they repeat these results in a figure, which is, well, maybe a couple figures actually, which is really helpful. So here figure 3 and then actually figure 4 as well show the isotope values for all of their samples. So you may want to take a look at which of these values are fully significant. And then here's where I started really marking things up because they really get into interpretation. On figure 3, asking you the question, what does this tell you about the type of diet each organism had in terms of herbivory, omnivory, and carnivory? That's one of the goals of this figure. And then to help you interpret figure 4, right, so that was figure 3 down here. Now to help you think about figure 4, you're going to need to, on this axis, they're going to explain that altitude is correlated here, I think, with collagen. So anytime they say that altitude is correlated with one of these things, draw it on the axis, right? Put an arrow here from low to high altitude here in any of the figures that relates, because that will become important to understanding their results. So what time in a bear's life does the delta 18 of oxygen represent. So hibernation or active period, and that will also help you interpret this figure. So you want to make notes about that. And then I went ahead and drew circles around each of the different species, right? Each symbol is a different species. Draw a circle around there and label it, with what it's telling you about where their altitude, where they're most likely found for altitude. Keep going with these other figures, and then I'm actually, once you get into the conclusion, going to have you go back and look at them again. So they're talking here about how temperature affects these values. So you're going to want to look back and see altitude and temperature and the relationship between those. And then they have their values here on the bottom there. And here's the French Alps value. And then they start talking about the low values of how these values are related to high altitude and activity. But keep in mind, this one is nitrogen and this one is carbon, right? We've been looking at ones with oxygen in them before. So for each graph, take a look at which isotopes are being used and what type of information they can give you about temperature, about altitude, about about size of the animal, about diet, and that kind of thing. So now at the end here, they're gonna give you their conclusion and say what they think that they supported. We're gonna take those and we're gonna go back and see which figure really supports each of those conclusions. So they and they do say that they have some difficulty, right? It's not entirely conclusive. So what were their original questions? Which figures support or actually try to answer those questions? And then in the conclusion, when they start to say what they found right here, and then continues on to the next page, and they have two different scenarios, right? So which scenario has more support? Which one do you think is correct? How would you test in the future to really sort that out? And then finally, they're going to give you sort of your broader picture, right? Why is this really important down here? So we're going to probably spend quite a bit of time on this paper. It may take us more than one class period because it is pretty complicated. On the other hand, you guys might get through it pretty quickly once you know how to annotate those figures with what each isotope is able to address. So read carefully, write your message box, and annotate every figure as much as you possibly can. All right, see you in class.